You're welcome. Before we get started on 4.2, are there any questions over the homework assignment for 4.1?
Oh, yeah, I do. I think it's the last one.
Okay.
I just honestly didn't know if I did it right. I'm not sure. I didn't quite
Number
get it.
19.
Yeah.
Number 19. So the function they gave us, let's see here, negative 2x to the fourth plus 12x to the eighth plus 17x plus 15x squared. So this here is the function that they gave us. Negative 2x to the fourth plus 12x to the eighth plus 17 plus 15x squared. And they wanted us to describe the end behavior. Within behavior, there's two things we need. We need the degree and leading coefficient. And for this here, the degree is 8, which would be even, and the leading coefficient is 12, and it would be positive. It's very tempting to say that the degree is 4 and the leading coefficient is negative 2, but again, the degree is always going to be the biggest exponent. Now what that tells us is that f of x, what it approaches is going to be the same thing, because with even degrees, they're either both going up or both going down, the y values anyways. So that means f of x is going to approach positive infinity and positive infinity as x approaches positive infinity and as x approaches negative infinity. And that's it. And we could have looked at the chart that we were given, so positive and even, and it would have given us the same thing. Any other questions on the assignment? What we're looking at today is operations with polynomial functions. So we're going to be looking at addition, subtraction, and multiplication. We will not look at division today. Now there's two ways we can add two polynomial functions. And the first one is vertically, up and down. So what that means is we can start off by writing the first one. So 3x cubed plus 2x squared minus x minus 7. Over our other one, and we'll line the terms up. So we have x cubed minus 10x squared. In my second one, do I have a term with x to the first power or just x? No. So we'll need to leave a little bit of a space and say plus 8. And again, we are adding. So we're going to add all of our like terms together. So first thing we can do is x to the third plus x to the third. So 3x to the third plus x to the third is 4x to the third. 2x to the 10th plus negative 10x, sorry, not 10th, 2x squared plus negative 10x squared. Negative 8x squared. Negative x plus, well, we do have anything to add to our negative x? No, so it's just going to come down as negative x. And lastly, negative 7 plus 8 is plus 1. That's it. We're just adding them together. Questions on any of this so far? Now, again, I said there's two ways we can add these. The other way is horizontal. Because vertical, when we talk about something being vertical, it's up and down. Horizontal, left and right. So what we're saying is that we have 9y cubed plus 3y squared minus 2y plus 1. And we're going to add to it negative 5y squared plus y minus 4. So we're going to add them together horizontally. Now, because we have a plus and there's no sign or number in front of either set of parentheses, realistically we can drop the parentheses. Because we do have to be careful with subtraction, because whichever one we're subtracting, we will have to distribute that negative through. Now we can put our like terms together, so we have 9y cubed. Well, the other expression, there are no other y to the third terms, so we can leave it by itself. Then we have plus 3y squared. Well, I'll move the negative 5y squared next to it, so they're like terms next to each other. We had minus 2y. Well, its like term is going to be plus y. And then we have plus 1 and minus 4. When we combine like terms, we'll have 9y cubed. 3y squared minus 5y squared is negative 2y squared. Negative 2y plus y is negative y. And lastly, 1 minus 4 is negative 3. That's it. Now, really, the step before we didn't necessarily need to have it, because if you wanted to go from here to here, that's perfectly fine. But again, just make sure you're keeping your signs correct. For vertical, yeah. Because you can add them vertically or horizontally. Either way works. It'll get you the same answer. Yeah, with addition, it really doesn't make a big difference. With subtraction, it doesn't make a big difference. Any questions on this so far? So we can add vertically. And if we do add vertically, and you stick with this one here, if there is a missing term, because here the biggest exponent we have is 3, x to the third is our biggest one. So x to the third, x squared, x, number. If we're missing one of those, especially for the one on top, I leave a blank. So if we were missing an x squared term, instead of putting x and not leaving a spot for it, I would leave a space and kind of space them out. That way, when we write the one below it, all the like terms will line up, and there will be a space for where one of them is missing. So we can say 2x cubed plus x squared minus 3x plus 4. And on bottom, well, we do have an x cubed term plus 7x squared. Well, again, they didn't give us a term with x minus 2. And again, we are adding. Now, whenever you do vertically, do make sure to line up the like terms, because it'd be very easy if you had the negative 3x above the negative 2. As you're working through it, it's very easy to just combine those. Now, when we add these here, 2x cubed plus x cubed is 3x cubed. We can go to the next one. Yes, x squared plus 7x squared is 8x squared. Since we don't have anything to add to negative 3x, it's just going to be negative 3x. And lastly, 4 plus negative 2 is plus . Any questions on any of this here so far? ready for the next one? And again, we can add horizontally. Negative 4y cubed plus 2y squared minus y plus 2 plus y squared minus 6y plus 9. Now again, we don't have anything in front of either of these parentheses besides the plus or a positive, so we can drop the parentheses, which leaves us with 4y cubed plus 2y squared minus y plus 2. We have plus y squared minus 6y plus 9. Questions on this so far? Now at this point here, we could reorder this here so the like terms are next to each other, but really what are we doing? We're combining like terms, yes? So looking at this here, our first number, our first expression is the negative 4y cubed, yes? Are there any others that have a y to the third power? No. So it's the only term like it, yes? Now we can look at the next one, which is 2y squared. Are there any other y squared terms? Well, yes, because we have 2y squared and y squared. And if we combine those, we get plus 3y squared, because 2y squared plus y squared is 3y squared, yes? Okay, our next one is y to the first. Well, we have one here, yes? Do we have another? We have these two here, yes? Negative y minus 6y is negative 7y. Then our next one is our 2 and 9 are like terms, yes? And 2 plus 9 is plus 11. Now the symbols I just put underneath the terms might seem a little weird. This is something I do even when I'm actually solving the problems myself. It's keeping track of the terms. I put the same symbol under each one as I add or subtract, as I combine them. That way, when I look back at it to see, okay, did I combine every like term? If I look back and see that one's missing or one didn't have the same symbol that it's supposed to, I can actually look back and check pretty easily, did I combine all my like terms? Did one get missed? It's an easier way for me to check. The other way is we could do like we did before, put them all next to each other and then combine. Either way works. Questions on any of this here? Are you ready for the next one? Because we're going to change from addition to subtraction. We're going to do vertical first. So we can put 2x to the third plus 6x squared minus x plus 1 on top. And we're subtracting it from 8x cubed minus 3x squared minus 2x plus 9. And we are subtracting. And I put the subtraction by each of the different terms, between each of those terms, just as a reminder to myself that I am subtracting. Because sometimes if these get pretty lengthy, we can get about halfway through and start adding by accident. It is very easy to do. So now that we have this set up, we can go on and subtract. So we'll do 2x cubed minus 8x cubed. 2 minus 8 is 6, and it would be negative. So we have negative 6x cubed. Then we can look at the next one. We have 6x squared minus negative 3x squared, yes? Well, a negative and a negative make a. So what I can do here is, right over the top of them, positive 6x squared plus 3x squared is plus 9x squared. Then we can go to the next one, negative x minus negative 2x. Well, again, the negative and negative make a positive, so negative x plus 2x is plus x. And 1 minus 9 is negative 8. And that's it there. Questions on this here? The way that we subtract horizontally or vertically really doesn't make a big difference. I think for some it's easier to keep track of the signs when we do it vertically than it is horizontally. Any questions on this here? So if we want to subtract these horizontally, we have 3z squared plus z minus 4 minus. Unfortunately, no, because our final answer does have z in it, yes? And the variable, or z we have here, is actually a variable, not a number, correct? So unfortunately, the 89 or 84 pluses and the TI-30XS's need the variable to have a value. So if it worked out that in the end we had a number, just a number, nothing else, but they all well, not so much they all simplified out, but we plugged a value in for z and actually evaluated it for a given value, we could. But with the calculators we have, they won't. The TI-89s, those will do it because it is smart enough to treat it as a variable, not as a number. But unfortunately, it's banned from the ACT, so, yep. It can do a whole lot of stuff for us. Now, with this here, there is one main difference between this and addition. Well, obviously, we're subtracting. But what we have to do is we have to apply that negative to everything in the second set of parentheses. So the first set is going to stay the same. But in the second set, instead of having positive 2z squared, we're going to have negative 2z squared. Instead of positive 3z, we have negative 3z because we're subtracting it from the first. But now when we combine like terms, we have 3z squared minus 2z squared. 3 minus 2 is 1, so we're just left with z squared. Our next one we have is positive z minus 3z. Positive z minus 3z is negative 2z. Our next term we have is negative 4. Is there another like term with negative 4? No, so it's just minus 4. Questions on this here? So on the homework, I will let you pick whichever method you like better, vertical or horizontal. We'll look at one more and then move on because I don't think we need to do too many of these with addition and subtraction. This is just reiterating, combining like terms. No.
We do the song. Oh, never mind. Just show.
So do we feel comfortable with these here?
Yeah.
Do we need to see another example of addition, subtraction? We feel good with this? Yes? No? You feel good? Okay. And again, if you do these on the assignment and have trouble with any of these here, ask, and I will work them out and we'll go through them and help you out there, okay? Now, the last thing we're looking at is multiplication, and we're going to look at a few of these here. Now, I believe on your note sheets it does specify that we're going to do these horizontal and vertical. We're just going to do these all horizontal. Vertical is a little funky, a little weird. We're mainly going to look at horizontal. And when we multiply these horizontally, we're just using the distributive property to multiply them together. So we can start off with negative x squared. So we'll do negative x squared times x, which is going to be negative x cubed. We good? Then we can do the next one, negative x squared times negative 3. Well, the negative and negative make a positive, 3x squared. Then we move on to the next one. 2x times x is going to be plus 2x squared. 2x times negative 3 is going to be negative 6x. And lastly, we're going to multiply with 4. 4 times x is going to be plus 4x. And 4 times negative 3 is negative 12. Combine like terms. Well, x to the third is by itself, so we have negative x to the third. That's kind of nice. The x squareds are already next to each other. 3x squared plus 2x squared is plus 5x squared. Negative 6x plus 4x is negative 2x, and then we have the minus 12. That's it. Questions on any of this here? Questions on anything we've done so far? Okay. Let's look at the next one. We're going to multiply these two together. Y plus 5 times 3y squared minus 2y plus 2. And again, we're going to do the exact same thing we just did. We're just distributing. So we can do y times 3y squared, which is going to be 3y cubed. Y times negative 2y is negative 2y squared. And y times positive 2 is plus 2y. Then we can move on to the next one with 5, distributing the 5. 5 times 3y squared is going to be plus 15y squared. 5 times negative 2y is going to be negative 10y. And lastly, 5 times 2 is going to be plus 10. If we combine like terms, well, (3y cubed) is by itself. There's no other like terms with it. But negative 2y because negative 2 plus 15 is plus 13y squared. 15 minus 2 is 13. Then we have our positive 2y and negative 10y, which would be negative 8y. And lastly, we have plus 10. Any questions on multiplication? Any questions on anything we've done so far? Do we feel good with multiplication? Do we need to see another example of multiplying two things together? Do you feel good with this here? Okay. So I think as y'all have come to expect, there's always something a little bit harder. So we want to multiply x minus 1 by x plus 4 times x plus 5. We're going to pick two of them to multiply together first. We can pick the first two and do exactly what we just did. X times x is x squared. X times 4 is going to be plus 4x. Then we can do the same thing with negative 1. Negative 1 times x is negative x. Negative 1 times 4 is negative 4. We still have to include the parentheses because we still have the x plus 5. Now at this point we can combine like terms. 4x minus x and be plus 3x minus 4. Questions on this so far? I'll do it again. X squared times x is x cubed. X squared times 5 is going to be plus 5x squared. Then we do 3x times x is going to be plus 3x squared. 3x times 5 is going to be plus 15x. Negative 4 times x is negative 4x, and negative 4 times 5 is negative 20. Then combine like terms. X to the third is by itself. 5x squared plus 3x squared is going to be plus 8x squared. 15x minus 4x is going to be plus 11x, and then we have minus 20. So is this here really any harder than what we had before? Just another step. It's essentially doing the exact same thing. We just have to pick two of them to multiply first, multiply those, combine like terms, and then do the other multiplication, and we are done. The order in which we do the two, which two we pick, really doesn't matter. Because I could have picked x plus 4 times x plus 5 first, done it, and then did the x minus 1, and we would have gotten to the exact same thing. Any questions on any of this here? I don't think we need to see another example of this. So this here, we've seen the first two of these here. Sum and difference of perfect squares. A plus b times a minus b is equal to a squared minus b squared. We had that. We factored it. So what that's kind of telling us and what we can use this with is if I have x plus 3 times x minus 3, it's going to simplify to x squared minus 9. So there are some, if we know what they are and kind of how they work, we can kind of jump a few steps. We don't have to multiply it all the way out. So with y plus 4 squared, it's going to work out to be y squared plus 8y plus 16. It's just working with the given equations to kind of help us jump a few steps, take a few things out. Or we can do it step by step. Either way is going to get us to the same answer. So if we look at this here, first one, 4n plus 5 times 4n minus 5. This is our shortcut, or just a difference of perfect squares. It's perfect squares factored, yes? because really we're saying that this started out as a squared minus b squared, yes? For a, here is our 4n. So really what I'm saying is I have 4n squared minus our b is 5 squared. 4n squared, 4 squared is 16. N squared is n squared minus 5 squared is 25. Now if we multiply this out, 4n times 4n is 16n squared. 4n times negative 5 is negative 20n. 5n times 4 is plus 20n. And 5 times negative 5 is negative 25. The middle terms would and we get the exact same thing, yes? So multiplying it out and doing like what we normally do will still get us to the same answer. One's a little bit faster than the other. Now this one here is working with our, this is a perfect square trinomial, which is in the form that ends up when multiplied out is a squared. Here is going to be minus 2ab plus b squared. It's just the general form. So for us here, if we worked it out, so a squared, and so 9y squared would be 81y squared, minus 2 times a times b, so 2 times 9y times 2. So that would be 36y plus b squared would be plus 4. Now, I don't see these here as being any more faster, especially if you're having to try to keep track of a squared minus 2ab plus b squared. But really all we're saying is that I'm multiplying 9y minus 2 by 9y minus 2. Well, 9y times 9y is 81y squared. 9y times negative 2 is negative 18y. Negative 2 times 9y is negative 18y. And negative 2 times negative 2 is going to be plus 4. So we get 81y squared minus 36y plus 4. Questions on any of these here? And again, with ab plus 4 cubed, we can do the exact same thing using the formula that they gave us to work it out that way, or we can multiply ab plus 4 times itself 3 times and get to our answer. Doing the shortcut. Yeah, because plus, let's see here, 4a squared b squared, because this would be, no, it's going to be 12, because it's 1, 3, 3, 1. 12a, because this would be 4 squared, so 16 times 3, 16 and 16, 32, 48, plus 64. There's 2 different ones, sorry. Because if we look at this here, because it's going to factor the a cubed plus 3ab squared plus 3ab squared plus b cubed. Well, a is just ab, so our first one's squared. Our second one, so we have 3 times b. Well, b was 4, 3 times 4 is 12. That's where we get the 12 from. The next one, 3 and b squared. Well, b was 4. 4 squared is 16. 16 times 3 is 48. And the last one, 4 cubed is 64. Let me clear all this out. You guys can watch this here and kind of see how this works. because we'd have a squared b squared plus 4ab plus 4ab plus 16 if we multiplied the first two. But we still have the ab plus 4. If we combine like terms, a squared b squared plus 8ab plus 16 times ab plus 4. And if we do this again, we'll get a cubed b cubed plus 4a squared b squared for this first one. Then we have plus 8a squared b squared plus 8 times 4 is 32ab. 16 times ab is plus 16ab. And 16 times 4 is 64. Well, 16 times 2 is 32. 32 plus 32 is 64, which would give us a cubed b cubed plus 4, not 4, because 8 and 4 is 12, b squared plus 32 and 16 is 48ab plus 64. And again, doing these with any speed, you're not going to be asked to do. I'm not going to make you guys try to do these in a time fast method. But any questions on this here? I don't think so, but if there is part of it, we know if it's cubed, the first and last terms are going to be ended up multiplying by themselves 3 times or that number of times. So 4 cubed is 64, ab cubed is going to be ab cubed. So we can narrow down our answer choices based off of that to know how it should work out. Now, Pascal's triangle is this here. And what this really gives us is the coefficients of what the numbers will end up being, especially if it's 1 and 1. Now, the way that we get this is actually really interesting, because we start out with a triangle of 1s. Here. This is always the setup. But here we have 1. And if we add the 2 above it, we get the next one. So we have 1 and 1 and 2. So 1. Here we have 2 and 1, which is 3. 2 and 1 is 3. Then we have the 1. 1 and 3, 3 and 3. And we get the next row. And the formula that we just had, if you looked at the previous page, because this here was our cubic, 1, 3, 3, 1. It gives us the terms in front. And the reason that this is nice is if we had something, say, x plus 1 to the 5th. So all the places that are a, so this would be x to the 5th, x to the 4th, x to the 3rd, x squared, x, because I just filled in all the places with a instead of a having x. Well, 1, there isn't any in the first, but we'd have 5, 1, 10, 10, 5, and 1 in the 5th is just 1. So x plus 1 to the 5th is that right there. So it's a little bit of a shortcut to get there. But knowing this and memorizing this isn't hugely important. But that is it. That is it for 4.2. And they call that Pascal's triangle also the factor tree, because it helps us factor out different things. And after Thanksgiving break, I will put my factor tree up, factor Christmas tree up. I drew one out, made it into a Christmas tree.